A lot of espresso drinkers have become loyal fans of the Niche Zero coffee grinder. Have you ever wondered if this stylish little gadget is sturdy enough to go the distance? You know, years or even decades. It's clearly not a heavy-duty machine and it wouldn't be suited to commercial use, but every now and then I read online that its build quality is below par. Is that so? Well, there's only one way to find out. So stick around while I tear down mine completely and show you what she's really made of. Oh my God.
It's like a miracle.
First, I'll remove the feed control disc and adjustment collar. I'm among those who like the disc, but not everyone is a fan. It certainly alters the grind dynamics and has an effect on flavor, so I'd recommend experimenting with it. I can say that in my experience, the only drawback is a bit of inconvenience during routine daily cleaning. You can't just unscrew the collar and yank the ring burr. For a complete teardown, you'll need 3 Allen wrenches, a 4, a 3, and a 2.5 millimeter. You also need a number 2 Phillips or posit drive, and of course the 10 millimeter socket driver supplied with the device. Opening the base, we find a couple of spare springs for the ring burr mount, and a chamber into which you can feed some excess power lead, both thoughtful touches. The feet are clever. Rubber inserts hold the wooden sleeves in place as if they were washers. But on the rear two, they're perhaps slightly too clever. The screw passes through the base and is anchored in the body, so I'll leave these 2 feet attached because once this slippery, larva-shaped body comes away from the base, it becomes awkward to handle. The top cover is a thick piece of polycarbonate plastic, durable with nice optical properties. It feels smooth and it fits perfectly. The ring burr carrier has 2 orientation slots with springs. There's some taper here to make it easier to start the burr when you insert it, but the clearance will tighten up when it's pressed down into the range where it actually works. So the play you feel at the top is just there to help you get it started without binding. I polished the bottom very lightly on a fine lapping stone to see how it looked. The width of the polished ring is consistent all around, indicating a precisely made part. You can see how the 2 burrs fit each other. They've got to be aligned radially and axially, or concentric and parallel. The question is, does our grinder maintain good orientation? The cone doesn't move up or down, the ring does. Making the grind finer is a simple matter of pressing the ring downward against spring pressure. The ring's upward travel, that is, going coarser, is limited by this inner ring on the adjustment collar that butts firmly against it. The adjustment collar moves up and down by means of these threads. Coffee can't push the burrs farther apart than the maximum distance you set. This is a hard limiter. They could come together closer than the distance you set, but the coffee itself exerts force against them, as do the springs. So these forces push them apart while the collar sets that hard limit. It's a simple design that works quite nicely. I consider it a good solution to the problem of keeping the burrs a certain distance apart with the proper radial and axial orientation while still allowing you to adjust them. Let's see how much slack there is. You're probably familiar with dial indicators, which have a plunger that usually travels parallel to the plane of the dial. The gadget I'm using here is a close cousin called a test indicator. Same idea, only there's a stylus that moves perpendicular to the plane of the dial, and the travel is limited to less than a millimeter. The resolution is 5/10,000ths of an inch, or approximately 1/100th of a millimeter. I'm going to move the ring burr manually in its mounting, without the springs. The maximum play here in both directions is 5/1000ths of an inch, or approximately 1/10 of a millimeter. However, I'm pushing back and forth from a single point, and that doesn't happen while it's working. Coffee grit starts to behave more like a fluid as it's ground progressively finer. Particles will flow through the gap between the burrs all around, so the ring really can't travel this far in normal use. In practice, the play is restricted because coffee forces the burrs apart more or less equally all around. It's not exactly self-centering, but that's the basic idea if you want to picture it that way. This is well within spec for espresso grinding. If it were not adjustable, it could, of course, be nearly perfect. But the fact that the grind size is adjustable means that there has got to be some play in the mechanism here. There also has to be thread lash, or the adjustment collar will bind. You can feel the lash by pressing down on the collar when the grinder is adjusted for use. A millimeter or so of lash measured by vertical travel translates into roughly 1 or 2 marks on the scale, so you get good accuracy, good repeatability. I commented before somewhere that I find the 0 easier to dial in than any other grinder I've used. I wrap PTFE or Teflon tape around the collar threads here to reduce lash and to provide some smooth resistance to turning, which feels good to me. I use it for another reason. This lightweight alloy is kind of soft and I am a little concerned about the stationary threads. This could become a point of failure for anyone who might handle it carelessly. If you get rough with the adjustment ring, over-tighten it, or torque it against coffee grit packed in the threads, there is potential for galling. A harder material would help, but there's always someone who can defeat the sturdiest design. Alright, let's look at the motor, the gearbox, and the electrical bits. The cone is mounted on this shaft, which also locates the 3-armed gizmo forming the wiper. Everything here is nicely machined. I'll remove them both, and now we can see the empty grind chamber. The floor has a plastic bearing carrier fastened with 3 countersunk screws. The 4th screw holds the chute. The carrier is a slightly flexible plastic. It's not glass reinforced, which I would prefer it to be, but as we'll see, that's a minor quibble. This bearing locates the gearbox output shaft that drives the cone. It's one of the crucial parts for burr alignment. Once we remove the bearing carrier, the motor rocks back and forth on its mounting studs below. We'll get to that in a bit. Some people have pointed to this as a weakness, but I'm going to withhold judgment for now. Let's see how good or bad it is when I measure runout on the shaft. I have to place the stylus below the keyway, so I hope you can see this. I am not the world's greatest photographer. Runout on the output shaft is a mere 5/10,000ths of an inch, or approximately 1/100th of a millimeter. And this is measured with the unit assembled as it would be in normal use, with all of the cumulative lash and play, and not with the drivetrain isolated on the bench. Look at that reading. It really doesn't get any better than this. Below the bearing carrier, we find a plastic spacer with threaded brass inserts. It's a good rigid piece. Notice that there is no coffee grit outside the grind chamber. When was the last time you saw that on an Italian-made grinder? The wiring is simple, direct, and cleanly routed. The PCB, switches, and connectors are all good quality. This is very nicely done. The motor is mounted on 2 studs. It has a removable carrier with rubber or silicone bushings. The motor can rock a bit, which means less vibration and noise. That's why it was set up this way. The motor mount screws are pre-treated with Nylock Blue Patch, a self-locking material that resembles Loctite but doesn't feel as effective to me. They're easier to turn than I would have them, but I also have no reason to be concerned. They were in place and snug. Nylock is reusable, unlike Loctite, so this is the better choice for home DIYers. I'm glad that someone was thinking about vibration here while realizing that the average person doesn't have a lot of tools and shop supplies. This is a quality motor, solidly made and well balanced. I have no issues with it. The planetary gearbox is made with nylon and Delrin parts. I've used this grinder daily for 5 months now, and there is not a hint of wear here. Everything is snug with minimum lash, and yet it turns freely, almost effortlessly. I'm actually quite impressed with it. If you're worried that plastic gears aren't tough, you should take apart your electric drill one day. Chances are, if it's not too old, you'll find at least some plastic gears. They can be more durable than metal ones, and they're quieter. The housing here is quite heavy, with threaded inserts again, and nylock. The output shaft passes through a bronze bushing here in the housing, and a ball bearing above, which we saw earlier, so it's well supported. Overall, there are no loose components, no rattles and buzzes, no sharp, unfinished edges inside or out. There's no issue with the motor straining or overheating or thrashing under a normal load. Every part of this device is smooth and pleasant to handle. Tolerances are nice and snug throughout. In other words, the build quality is very high. So why do some people question it? Because they don't understand the difference between build quality and duty rating. The Zero is not heavy duty. It's not some bulletproof shop grinder designed to run 10 hours a day for a decade. It's a home appliance that's going to grind at most 100 to 150 grams of coffee per day. Okay, maybe 200 for caffeine-aholics like me. In typical home use, the Zero will be working under a load for around 2 minutes per day, or about 12 hours per year. The idea that it's not tough enough is preposterous. So, I hear you wondering, is there anything I don't like? Well, this dosing cup is kind of a fail. It's out of round, so it doesn't fit my 58mm basket, and it can't fit anything smaller. I get a lot of static cling with it. I think Niche should look into a completely different dosing cup. Second, if this was my only grinder, I'd want a hopper capacity of 60 grams or so for pour-overs. But since I use it primarily for espresso and Turkish coffee, the range where it really excels, that's not an issue for me. As with any conical burr grinder, the bigger you set the overall particle size, the more likely it is that the high proportion of fines will become problematic. This would not be my first choice for pour-over. But if you have this or any other quality conical grinder and you enjoy pour-over coffee, you're in luck. I've got a recent V60 guide that explains how to compensate for a higher proportion of fines than you might prefer. So do check that out before buying another dedicated grinder for brewing. I don't think it's necessary for most people. You can adapt your pour-over technique to conical burrs as I demonstrate in that piece. Well, that's about all for today. Soon I'll have a full report on the 9-barista espresso maker and a follow-up to my new V60 Voodoo method with some advanced tips and tricks, just as I did with my original Mocha Pot Voodoo. So keep in touch. Cheers!